Can you tell us your name and a little bit about your project?
My name is Rosalind Franklin, and I photographed my 51st diffraction pattern of DNA, which provided information about DNA's three-dimensional structure by displaying the way a beam of X-rays scattered off a pure fiber of DNA. Here's it here.
What were you guys trying to do or find?
I was trying to improve my methods of collecting DNA X-ray diffraction images, so I attempted an X-ray crystallography experiment.
Where did the project or the experiment occur?
On May 6, 1952, at King's College, London, in London, England.
What other significant events were happening around the world at that time?
Many significant events were happening in the world in 1952. Elizabeth II becomes Queen of England and the United Kingdom after the death of her father, King George VI. The Second Sino War ends when Japan and China sign the Treaty of Taipei. The Mau Mau Rebellion starts in Kenya. Also, unfortunately, 3,300 people died of polio in the United States. In fact, 57,000 children were paralyzed from this horrible disease. I am not a parent, and I do not have any children, so I'm very lucky that I am not a parent of one of those poor children that were paralyzed. However, my team and I, including my colleague Dr. Klug, are actually doing research on the poliovirus.
Who else was involved in the project?
I worked with my graduate student Raymond Goslin.
What was your role in the project?
I conducted the X-ray crystallography experiment. First, I minimized how much the X-rays scattered off the air surrounding the crystal by pumping hydrogen gas through the crystal. I did this because hydrogen only has one electron, so it does not scatter X-rays well. Next, I pumped hydrogen gas through a salt solution to maintain the targeted hydration of the DNA fibers. Then, I tuned the salt concentration of the solution and the humidity surrounding the crystals to keep DNA entirely in the B form. After exposing the DNA fibers to X-rays for a total of 62 hours, I collected the resulting diffraction pattern and labeled it number 51. That later became photo 51.
What impact did your project have on the physics community?
I indicated that DNA was likely to be a double helix with anti-parallel strands and that it had a phosphate backbone on the outside.
How did you get into X-ray diffraction and DNA?
I knew I wanted to be a scientist from a very young age. I tried very hard in school and was accepted into the University of Cambridge, where I studied natural sciences and graduated with second-class honors. This is not something I'm happy about though, because I'm kind of known as a perfectionist. In 1947, I moved to Paris, where I worked with Jacques Mering at the French government Central Laboratory, where Mering was working with X-ray diffraction of amorphous solids, or solids like coal with no regular crystalline structure. It was at Mering's lab where I became an expert in X-ray diffraction, and after moving back to London in 1951, I set up X-ray equipment to take X-ray diffraction images at King's College, University of London.